Well, good morning. This is Bill Ragsdale. It's a pleasure to be here by delayed tape recording for the fourth interest group here on February 25th. Today, we're going to discuss the fourth words for next generated in high-level form. For and next kind of joined the fourth community in the year 2000 or thereabouts. I think one of Chuck's chips used it, and it was picked up by Dr. Ting in some of his work on fourth generated and by C. It borrowed its syntax from BASIC and many other languages. Essentially, the number before 4 sets up the number of loops. So 5, 4 will set up a loop structure for 5 loops. However, the loop does go through n+1 executions because it goes down from the starting value through 0. Then the word next loops until reaching the zero index, and then it continues execution ahead. So my goal was to write for next in high-level fourth for portability. I just wanted to add it occasionally into the language, not necessarily make it a permanent part of my installation. And I was going to try to avoid code definition as I was intimidated by the Intel machine code structure, and to a fair degree, I still am. So my first cut at the process was to use do loop as a model. Do takes 2 loop parameters. In this case, I only wanted 1. And with loop, I wanted to branch back to the beginning do, maintaining the counting, the loop counting. Traditionally, this is used a branch and a query branch to do the physical branching. And then you put a little preface on it to set up the loop values. So my definition was to compile a definition of underline 4 as the setup, and then the branch, which would do the forward branch when needed, and then next would compile an underline next, and then the query branch to branch back to the 4, and those other values of mark and resolve handle the looping structure. The low-level forms then would be to compile the underline 4, which goes into the return stack and puts the parameter values in place. Then the following underline next goes into the return stack, pulls the values back, does the manipulation, and the exiting true and false controls the branching. After I got this fairly well running, my discovery was that the words of I and I prime and leave do not work. Well, I gives us the current index value, and I prime gives us the limit value, and leave lets us exit the structure prematurely. And with my format, these wouldn't work. Digging into the machine code, I found out that Win32.4 pre-adjusts a loop control in a very innovative way. It offsets the loop values to very high integer values, such that on the loop limit, you get an overflow, and that terminates execution. We'll see that a little bit later in the pure code form. But this was way beyond what I could do with the adjustments to in high level using the fetching and storing into the loop stack. So, and also the setup math was quite complicated. So I thought, well, let's try to use do and plus loop themselves. I can adjust the loop value before the do to get it to simulate what I want on my 4. And then I can use -1 plus loop in place of next to do a loop back and a declining increment. So in this case, my words got pretty simple. The underline 4 was just a 0 swap, which would put the loop limit in place. The underline next would put a -1 in, which gave me a plus loop in a declining increment. The compiling words were very simple. The forward just compiles the underline 4 ahead, and then it relies on the full do word to compile the rest of the structure. Or at the next, we would compile the underline next, and then use the plus loop inline to complete the rest of the structure. Pretty simple. To test it, then I set up a loop for 5 steps. The 4 next brackets the CR1 -1 dot to do a new line, get the loop index, and print it. Sure enough, on execution, it goes 543210. That's a success. Well, then I thought, my underline 4 and underline next are so short, why don't I just compile them in line? So again, I went back and I grabbed the do and plus loop and modified them, and I compiled in place the parameter adjustments. Now we see the words are, for 4 is compile a literal with a 0 to begin, and then a swap. So this sets the ending index. The runtime index will be on the stack. Then it uses the do, compiles a full do to do the control structure. Similarly, for next, I just compile a literal of -1 leading into the plus loop. This gives it a declining count. And now I have 4 next done in just 2 high-level words. I was even shocked at the simplicity. To test them, same structure, test number 3, we put a 5 on the stack, we call 4. It will then loop 6 times, each time getting a new line, printing the integer, and sure enough, we see 5, 4, 3, 2, 1, okay. The result for this method number 3 was 2 simple definitions. It builds on proven concepts. Reading the code is easy. The understanding is super easy. But I did run into one bump. Win32 fourth has a beautifully developed decompiler called C, and it has a disassembler that will disassemble machine code, and it restores them into identical structure as to the original. But I found in this case, the decompiling gives me my do and my plus loop, which of course are the primitives that are compiled in place. And so this is a little bit messy. I thought, well, what would it take to modify the decompiler? So I go into the decompiler and I find out that whereas most forths use branch and query branch to build the conditionals, instead, Win32 forth defines each conditional as a code word by itself. So do, loop, if, begin, and so on, all are written in machine code, and they are individually discrete because they can be associated with a high-level word for the decompiler. So even a couple of words are no-ops that are compiled in line. Then and begin have no control function. They're just markers at return points. And so they even have primitives, even though the primitive is a no-op. You get a little bit of speed loss, but you get clarity in decompilation. I went into the decompiler and looked at the c.f file, and I find that for do and loop, the entries are given here for their decompilation. For the paren word, so manipulation is done, and it displays the word do. The latter line, second line for plus loop, after through decompilation, it will say the word plus loop. So if I were to modify these, I could add these 2 words to the decompiler. But wait, there's more. In order to get this in operation, I actually had to go into machine code and understand the operation of the Win32 fourth, paren do, and paren plus loop. So after learning the machine code, I realized that I could actually rewrite them very simply to get them to insert the values that would convert the words into primitives for for 4 and for next. So here is the code I came up with. The code for this underline 4, the 4 primitive, I only had to add 1 line of code, and that was the move exec comma #0. This puts the loop limit into a scratch register, and the rest is taken care of by the standard word for do, paren do. To modify or to create my word for underline next, in this case, it pushed the stack to make room for this new value, and then move onto the top of the stack the immediate value of -1. Bingo, that sets up the loop increment. To compile this, again, I modified the prototypes for 4 and plus loop. I modified the words for do and plus loop. In this case, we compile the underline for. Mark sets a return point. On next, we compile the underline next. The remaining couple of words resolve the branches. And to test it, we do test score, the same one we've always been using. We input with a starting value of 5. We do a return, an I and a dot, and sure enough, we get 5, 4, 3, 2, 1, 0. So it works too. So here I have 3 different methods of doing for next. My conclusion was that the high-level 2-line solution was the best. It's obvious, it's clear, it's clean, it's portable. And I can live without modifying the decompiler since it isn't used that often, and I know the difference. And I did not have to fear machine code programming, or I have learned not to fear machine code programming. So that summarizes my work on for next. I've added into my arsenal of fourth tools. And so now we will go back to our fearless leader at Win32 Fourth Central.